In number 65, we are going to solve this inequality. So I'm using the properties of absolute value inequalities in order to solve that. So the first thing I need to do is isolate the absolute value on the left, which you can see is already done. So then I look at which one of these properties does this one look like, and that is a strictly less than, so that's property 1. So that means what's inside the absolute value is sandwiched between 1/2 and -1/2. So I'm going to rewrite this inequality without the absolute values. So actually, you know what? I usually start just by taking the absolute value bars off. And then when I flip the sign, I know that and change it to a negative, I know that that means it's going to be sandwiched. So then I have it's greater than -1/2 and less than 1/2. All right. Now I need to isolate the x. So I'm going to do all 3 parts of this inequality at the same time. So I'm going to add 1 to isolate that term with the x in it. So, subtract 1 from both sides, all 3 sides, which gives me -3/2 is less than, and then in the middle we have the 1's cancel and I get the -2x. That was my whole goal. And then on the right I have 1/2 minus 1 is -1/2. Now I have to get x by itself, which means I need to divide each term by a -2. When I divide an inequality by a negative, you can think of these as dividing by -2 also. I'm taking the negative of every piece, which means my signs have to flip. So those become positive. Or not positive, sorry. A less than becomes a greater than. A negative becomes a positive. Positive becomes a negative. Greater than becomes a less than. Everything changes. Everything flips to the opposite. Okay, so -3/2 divided by -2. I'm going to do that off to the side here. Sometimes it gets a little confusing with complex fractions. So 3/2 divided by 2. I know it's going to be positive because it's a negative divided by a negative. So I'm just going to keep it positive. 3/2 divided by 2 is the same as making that 2 into a fraction by putting it over 1. And then flip the second and multiply, which gives me 3/4. And then in the middle, my -2's canceled. That was my whole goal, to get that x by itself. And then I flipped my sign, so I now have greater thans. And then I have on the right, I have the -1/2 divided by -2. So it's negative divided by negative, so it's going to be positive. And I'm going to do the fraction over here. So 1/2 divided by -2. So I can make that -2 a fraction. And then flip the second. Oops, sorry, I decided to keep it positive since I'm negative divided by a negative. 1/2. Flip the second and multiply, so now it's 1/2, and I get 1/4. So that means my my x is sandwiched between 1/4 and 3/4. Now the order of this kind of got convoluted because I flipped the sign, so I'm not going from, my intervals are no longer going from least to greatest. So really I want to flip this whole thing around, reading it from right to left, and then writing it again. So as I'm reading it from right to left, it's really 1/4 is less than x. So 1/4 is less than x is less than 3/4. So on a number, I like to do a number line when I make my intervals because it's pretty visual. So once I put it in order, 1/4 is less than 3/4. So on a number line, it's on the left. I know I'm going to have open circles because it's strictly less than, no equal signs. And I want that space in there. And that gives me the interval starting at 1/4 and ending at 3/4. That's my final answer. So x is somewhere between 1/4 and 3/4. So you can see, you'll often see this as the final solution. In this textbook and your test will often ask for the interval notation, so that's the interval notation, and that's what we'll be using as our final answer. But I just want to note that this is a pretty common way to express that final answer too. So in your future math endeavors, you'll probably see that too.